Hi class, today I will share with you what is process capability. Process capability is under course outcome 3. That is ability to develop the process capability in engineering application. The learning outcome for this chapter is process capability analysis and how you apply it in engineering problem. Next is the scope of this title. First is the concept of process capability, definition of process capability. Then we will go understand what is process variations. Then we'll analyze the process capability index and process performance index. For information, process capability index and process performance index is a calculation part. I will cover in the next video. Okay, first, what is the concept of process capability? That means, what is process capability? Process capability, the function is look like a crystal ball. What is the function for crystal ball? It's predict your futures. Predict what will be tested on next coming few weeks. So the crystal ball function is to predict the future. Look at the sign of your futures. So in the production line, impossible an engineer bring a crystal ball to the engineering and manufacturing department to predict the process, to predict the quality of the product, isn't it? So they have a tool. It's very powerful. The function seems like a crystal ball. That is control chart. Control chart. If you're doing the good control chart with accurate data collect from the process, you can predict the process accurately. So the control chart function is used to predict the process performance for your product. Therefore, the concept for process capability is to ensure the process should be stable, capable to produce a part that meet the specification. Process capability is a quantitative prediction method to predict the process effectiveness and ensure that the product is robust in the dimension and the quality. The process capability is measured by the variation of the product which produced from the entire process. Therefore, the definition for the variation is very important. You have to understand what is the variation for your process. So, next, I will discuss about the variations and the process. First, what is a process? Process consists of combination, machine, method, material, man, environment, and the measurement. This 4M and 1E is same as a fishbone diagram as you learned in chapter 8. All these element sources will create variations in your process. So a process is you put something in the process, the input, the raw material will come out a product. So the process variable will influence the final product quality. There are various variations in your process, such as uncontrollable and controllable issue. Uncontrollable, that is a humidity and temperature, scale of the labor. Controllable issue, that means machine setup and flow rate, feed quantity. Besides that, also have the raw materials variable in the raw material components, equipment, operator method. All these sources will influence the variation, the products of the process. Therefore, The purpose of the process capability is to narrow down all the variation in the process, so that you can meet the requirement of your customer. Narrow down the variations, stable your process, produce robust product. The key point for every process have the input just mentioned just now, that is an uncontrollable input. Then if you can control all the sources, that means all the input from the process, that means that it is a stable process which can produce lesser variation product. Please look at this chart here. For example, assume I'm your customer. I need you to produce a product. The dimension, the length of the product is 2.1 mm. Then the upper limit I can allow tolerance is 2.3 mm. If you your process can get 2.2 mm, that is a perfect dimension for me. So if your process, this is your process data, isn't it? Process data. So your process data here, the product, always produce a product is between 2.1 to 2.3. That means under my tolerance range, your process is capable. If your product always produce, the data is something like this. That means all here is defect, here is defect. That means the dimension is below 2.1 or bigger than 2.3. So this is what I don't want. This one I will reject. So that means your process is not capable enough to fulfill my requirement. Understand? I hope you understand with this example. Then, why have the variations in your process? So, type of variation in the manufacturing process. First one, within the unit. That means the position for the variation. One ruler, if you measure the thickness from different location of the ruler, you will get different value. That is variation for within the unit. Second one, between the unit. That means you have 3 rulers. You measure with the same locations. That means it's a center point. 3 also center point have a different value among the 3 rulers. That is between the unit. Time to time. Different time has a different reading. That is mostly involve temperature difference or changing of humidity. Normally it's a sinkage problem or wetting problem of your final product. Then lastly is a measurement error. That means the equipment for measurement is not accurate. Skill of the operator is not good enough. So always have the error in the measurement. Thus, all the different type of the variation will come from the materials, tool, operator, method, machine, environments. The example for the variations in each type is shown here, such as tool wear, machine vibration, tensile strength for the materials difference, personal problem, temperature or humidity problem. They also reported that variation risk is due to the inspection activity. Variation may be due to the cause of the chance of the causes, that means natural causes and assignable causes. The variation due to the natural causes normally is unavoidable, but the operation or the process still in statistic control. That means the product you produce, the value, that means the quality, is still among the UCL and LCL. No any outlier happen. This is normally due to the natural causes. What is an example of natural causes? Such as vibration in the machines, temperature difference, normal wear of the tool, machine setting a bit difference, computer delay response, human response to the traffic light system difference. And how to reduce this kind of the natural causes? First, change in the process technology by change the product, maybe do some maintenance for the process. Change the design a bit so that you can reduce the operator error, mistake, such as Pokayoke. Pokayoke is a good method to reduce a human error. That means you design a shape difference between positive and negative sign, so that the supplier, the operator won't assembly wrongly. So this is the method to solve the human error. Next, assignable causes. If the variations happen is due to the assignable causes, that is a serious problem. You have to solve it now. You cannot leave it because it will destroy your production line. This is a serious causes have to solve immediately. First one, incorrect setting assignment, adjustment, machine. Operator won't know following the instructions. Defect of the materials, raw materials, broken part of the tool or the design, wrong procedure, poor production design, no maintenance at all of the machine, lack of understanding, miscommunications, poor working conditions, that means lighting problem. So all these causes have to solve. That means it's a vital problem. If you get the control chart like this, that means still under control, only one point is outlier. Only one point is outlier here. Please bear in mind, if the trend is getting higher and higher, see, that means getting is outlier toward the outlier trend, please do the improvement to reduce it. So the process variations, if your process variation is from the natural causes, you can able to predict the response or the quality of the product in the futures. If your process have assignable causes, you are difficult to predict the quality of your process. So you have to solve the assignable causes to ensure your process is stable and predictable. This is a requirement for the customer. Therefore, for today, before I end up this video, let me do some cashback about the process capability. Process capability, the concept is stable and capable of a process. Quantifying prediction the performance. Measurement of the variation on the product. How about the variation is come from the sources come from the 4M, 1E. Then normally is from the natural causes can solve by Pokayoke. Assignable causes have to solve it immediately. Outlier point from the control chart. Lastly, process with the natural causes is capable and easy to predict the performance. Thank you for today. If you don't understand anything, please leave me a message. I hope you enjoy it. Thank you.